Hello, so my name is Delphine Tardif. I'm finalizing my PhD at the Physical Institute of the Globe in Paris, and I'm going to present you my poster. So we are at AGU 2019. So the main interest of this work is to study the onset of the monsoon in Asia. Usually the onset of the monsoon has been proposed to be around the Miocene, so around 20 million years ago. But actually we have some recent findings in different regions, for example in Myanmar or in eastern China, so you can find it around here or here, that are suggesting that the climate was actually highly seasonal during the Eocene, which is about 40 million years ago. And it has been interpreted as early signs of monsoonal circulation at that time. So we are trying to test with a modeling simulation, like using a fully coupled Earth system model. So modeling the ocean, the atmosphere, and the vegetation response to this kind of changes. And we are trying to see if we can actually model a monsoon during the Eocene. And since this period is actually a crucial moment where the India and Asia blocks collided, and it's still not very clear if they were fully collided at that time and if the Tibetan plateau was already fully uplifted, we're actually trying to test different paleogeographies and see which one is yielding the best results when compared to the data. So you have here our reference simulation with a 3,000 meters high Tibetan plateau and a fully connected India and Asia. We're also testing a slightly different form of Tibetan plateau, a remaining seaway between the two continents, no Tibetan plateau at all, or a higher Tibetan plateau. So the first step of the study was to compare our result with the reference simulation to the control simulation, so to the modern day circulation. Actually, what we yield is a really different kind of circulation, both for winter and for summer monsoon. So if you look at more closely to the wind, you cannot really say that you have a monsoon circulation at that time. But usually the fossils that we see are not recording the wind direction, but they are recording the seasonality in the precipitation between the winter and the summer seasons. So we have an index here that is quantifying this seasonality. And for example, here in the modern monsoonal region, this index is pretty high, so you have the dark blue shading here. And actually we can see that on the border of our really dry region, we are modeling a highly seasonal region. And in this region, this is where you can find your fossils that have been used to infer the presence of the monsoon. So we are suggesting that we might have a totally different circulation patterns yielding the same kind of seasonality. And when you just take a short look at the influence of the paleogeography, it's actually pretty stable overall, depending on the geography that we use. But we have an interest in this configuration where you have seawater that is remaining between both continents. This is the only way we can manage to have a bit of precipitation over the Tibetan plateau, and it's actually yielding the better results, like the best agreement with the proxy that we have so far. So it might be a good thing to discuss with the community and to say maybe this could be a good argument to help people decide between all of these scenarios that are debated today. Thank you.